I don't know. We're going to have to play some things by ear, as they say, because we're really in uncharted waters here. And we're going to have to kind of figure things out together as we go. Okay, so 8:20. I'm going to go ahead and get started. Can everybody hear me okay? Thank you. As you can see, the plan is to record each class session. So there will be a record of that will be available to everybody. I will send a link to the video, but it will be housed on our class's YouTube site, which if you follow the links of the videos I sent you already, you've been there. Okay? That's going to be the video warehouse for this class. Okay, so first let me say welcome to everybody. This is a crazy time, no doubt about it. It's always stressful, especially if you're a first-year college student, but I understand. It's really tough right now. And as far as this class goes, I suspect you still have lots of questions and doubts. I gave you a lot of stuff to absorb already, and it can be intimidating. I get that. So we're going to try to get everybody up to speed, okay? Like a machine building up momentum. Okay? But we're starting from rest. So it's not easy. It's going to take some time. The main thing is to reach out and ask me if there's something that you're not clear about. What's due when? Where should I find this? How do I do that? Better to ask, right? Even if you feel like it's a stupid question. Don't feel that way. Okay? So our procedures in the era of coronavirus are everybody has to have a mask. That means we're not really going to be able to eat. Okay? You can take a little, but a lot of this up and down with the face mask is probably not a good idea. We'll sanitize. These buckets are supposed to be here each day. I recommend you sanitize your work area just to be safe before you sit down. I also ask, if possible, kind of take a look at where you are. If we could more or less stick to this in case we have to do contact tracing later on in the semester. If people are sitting in the same place, at some point in a few days, I'll probably take a photograph of everybody in their current location. And that might help if we need to do any tracing. Obviously, if you're not feeling well, don't come to class. You can send me an email if you feel up to that, just to let me know. But better to be safe than sorry. Okay? These classes will be video recorded. So you can at least watch them after the fact. Right? Okay. If you are feeling well, please do come to these face-to-face sessions. I'm hoping that you'll find them very beneficial for clearing up the confusions you have. Okay? About the homework, about the video lectures that I will be sending to you on a regular basis that you're supposed to watch. Okay? So please do attend if you are well. I hope that you will find it very useful. Okay? Okay. Hello, everybody who came in. If you want, you can take a couple of these sanitizing wipes and wipe off your tabletop just to be safe. Okay? Okay. Now, did everybody get my welcome email a couple of days ago? There may have been somebody who didn't get this. Would have come on Wednesday, I believe. Okay? A lot of stuff there that I want you to absorb over time. For example, the syllabus. A lot of information there. I urge you to read it in its entirety. Okay? I already did urge you to do that, right? It's like our contract. It's explaining the rules of the game, how we're going to operate, how you're going to be graded, okay? All those kinds of very important things. So you can read this, okay? Which I sent to you. It also can be found on the Blackboard site for this class, in case you can't find the email where I sent that. I also sent you instructions for how to get access to Wiley Plus. And I know from the questions I've been getting that some of you are getting onto that site. There was a flyer I sent you that if you print it out looks like this. Very important. It's got the course code. That's what you have to use to find our Wiley Plus course. First time, you have to use this. Then you create an account. You pick a username and a password. At that point, you also have to decide how you want to purchase, because this is the textbook, okay? And as you know, textbooks aren't free. So that's what you're paying for. You're buying the book when you go to Wiley Plus. It's not a print book, it's digital. Why? Because it's entirely interactive with many questions where you enter answers. Our homework is going to be there, for example. Okay? You can't do that with a print book. It is purely digital. Okay? But this is the book, so it's not optional. If you have a little bit of a financial situation, you may have noticed it's got a 14-day grace period option. So you can get in there, get an account, and you've got 14 days to figure out how to pay for the access. What is the access? 100 and something, the cheapest, right? That gets you the book for the whole school year, Physics 110, and if you go on, Physics 111. Okay? But you do need this, because this is where all your homework will be done. What I call homework, Wiley Plus problems. Okay. I also sent you a video with instructions on how to navigate through our Blackboard site. That's the other place you're going to be going to. bb.owu.edu. Log in with your OWU username and password, just like it's email. Click on Courses, and you'll find all your courses that you're taking this semester. Click on the one for this class. Physics 110C is this class. And then you will find all that stuff that I showed you on that one video I sent. In that same video, I also showed you what you can find if you burrow into Wiley Plus and start looking at the actual content, i.e. the book. Just remember, when you're on Wiley Plus, you're basically have your book open. Okay? And I sent you a questionnaire, old-fashioned questionnaire that I asked you just to respond via email so I can get to know a little bit about each of you. Thank you. Most of you have responded. If you haven't, please still do. Okay? It's important that I know a little bit about you. Okay? Okay. Any questions so far? You are allowed to ask questions. Just do something like that. Yes. Yes.
This is for the Wiley Plus thing. If anyone's having trouble financially, you can always go down to the bookstore and charge it to your account for next semester.
Oh, very handy. Yes, I think that's a new thing now. So you can charge it to your OWU account if you buy from the bookstore. Anybody bought from the bookstore? So what is it? Is it a little packet or something?
Yeah, it's like a little small box.
It's a small box. The key thing in that box should be a code. That's how you get into Wiley Plus. Okay? Good point. Thank you. Yes?
Will you be teaching this class next semester, 111?
That's the plan. Barring something happening. Okay? Now, I want to say just a word. If you've read the syllabus carefully, and a number of you have because you've started to do this next thing I'm going to talk about. Hi, love. That's his name. Go ahead and take one of those wipes right there. Pick an open seat and wipe off the tabletop if you would. Just give it a yank. You might need two hands. Okay. I want to say a word about what's called our department's assessment test. A couple have looked at that and have been kind of flummoxed by it, which I understand. I want to make clear, the purpose of this test is not to weed people out. If you can't do this, you can't take this class. That is not the purpose at all. The purpose is for our department, physics and astronomy, to help us assess our whole curriculum. So entry students take a pretest, and students at their senior year take a post-test, and then we can measure the gain. Does that make sense? Of course, the pretest is going to be pretty sparse. You're not going to know how to do a lot of it, right? Why would you? It's not meant to say, if you don't know this, forget it. You can't do physics. It's more like, this is the stuff you will learn. For now, just try your best. Just think what you might think is the right answer and write it down. Does that make sense? So don't let it get you down. Think of it more like a preview of things to come if you study physics or astrophysics or pre-engineering. Okay, but in order to stop people panicking, I took it off the Blackboard site for a little while. I'm going to put it back up later today. Here's what happens. If you help out our department by taking that test, it's got a set of questions. You just get out a blank piece of paper. You put your name and the date, as the instructions say, and you write out what you think are the answers. Try giving it your best shot. And then what we're going to do a lot, probably, is snap a pic. Hopefully, like if you get like CamScan app or something like that, you can make a PDF, and you can email it to me. Does that make sense? If you do this before next Wednesday, it's got to be early in the semester before you start to really learn a lot of physics. If you do this by next Wednesday, when I compute your grade at the end of the semester, I will drop your lowest 2 quiz scores. Okay? All right. Hopefully, does that make a little bit more sense? If you don't have that context, when you see that assessment test at first, it's easy to freak out. Don't. It's okay. But do give it an honest effort. Just try what you think is the right thing to do. Okay. So this class also has a lab that goes with it. Separate class, 110L. You have to sign up for it independent of 110C. It's 2 classes. This is a 1-unit class, 110C. 110L is a 0.25 unit, quarter of the unit, right? There is either a Monday section, section 1, or Tuesday, section 2. You have to be in one or the other, not both, okay? Everybody must be in a lab. You must take it concurrently with Physics 110C. We will start next week. So if you're in the Monday section, we'll have lab Monday afternoon. Otherwise, you'll have lab Tuesday afternoon. The labs are over in the Science Center. After all, you need to be where our labs are, where our equipment is. Okay? The Science Center. SCSC is the building code. And it's going to be in rooms 130 and 136. Probably says 136 on your schedule. And that's fine. You can go just there. But we're going to spread out between 2 rooms because we need to do physical distancing. So labs will start next week. You don't have to purchase anything. You probably would find a laptop helpful. A calculator would be helpful. Normal things you would bring to class, like something to write with and on. But we will provide all the equipment. There's no book to buy. The book is a lab manual that we provide to you, free of charge. It's on Blackboard for 110L. 110L, separate class, remember. If you go into 110L, you'll find the lab manual. It's just a PDF file. What I'd like you to do before the first lab is open up that PDF file, look around at it a little bit just to get acquainted, but mainly read at the beginning, you'll find a section labeled syllabus. You'll want to read that. Okay? And if you want to know, we'll be starting next week with experiment 1. So you're certainly welcome to look over that experiment in advance. Might make you more efficient. Any questions about lab? I'll have another reminder on Monday's class about attending.
Will we need to print anything out? Like, are we marking stuff up in the lab manual for data collection?
No, you'll be using everything will be on the computer. Okay? Okay, the workflow. How will things kind of go with this class? Because I said I want to build up some momentum, a kind of a rhythm for how this class will work. So as you know from the schedule, we meet in FACE, for those of you that are on campus, 3 days a week, Monday, Wednesday, Friday. This time, this place, as of now. Okay? So, again, if you're feeling well, please attend. We do have a 4th class, but it's a bit different. I call it a Thursday class because in the old days it was on Thursday. But it's not face-to-face. It's all independent. You work on your own on Thursday. I'll send you videos with some exercises in them. And I'll probably send them out on Wednesday evenings and say, hey, by the end of the day Thursday, make sure you watch these videos, and if there are any exercise with it, do the exercise and send it to me. So you do have physics class on Thursday. We're just not all together. Does that make sense? This class has always meant to be taught 4 days a week. It's been designed that way for many years. We only meet 3, but there still is that 4th one. So just don't forget about it, that Thursday is also a physics day. But you just do it on your own. Okay? That makes sense? Okay. I'll be making lots of video lectures. You're already starting to get them. I'll be sending them. For each face-to-face, there'll be a video lecture to watch before. Okay? Almost every class. Not one for Monday, but otherwise, almost every class. I'll be sending you a video lecture to watch before you come in here. And it's really important that you do watch it. Probably ought to even take notes on it, as if I were up here lecturing to you. Because that's where the ideas are introduced. And the class is, okay, you've already seen the ideas, now let's start practicing. Using. Does that make sense? So, if you don't watch the video, what I do here is probably going to go, oh, what is he talking about? Okay. Even if you have to skim through it, you got to get the ideas from the video before. Except for Thursday's class. You just do that on your own. Okay? Okay. By the way, if you want to know what that's called, it's called a flipped classroom. If you want to know the fancy terminology. Homework. Homework is done on Wiley Plus. Also, if you want to actually read the book, which I recommend, it's there on Wiley Plus. Okay? I'm not assigning you to read the book, but I do urge you to do it if you can find the time. Okay? The book is Wiley Plus. That's where the homework is. It's online homework. In fact, if you've been on Wiley Plus, you've seen there's one assignment already, haven't you? You've seen it there? It says, this class has one assignment. And you click on that link and it'll take you to it. It's like 5 or 6 problems. And these are what I call word problems. They give you a situation in words. Sometimes there are pictures and graphs. And then ask you a series of questions. You're going to need a notebook of some kind with paper so you can work them out. You're probably going to have false starts. You're going to say, oh, wait a minute, that's not right. Just cross it out and start again. Okay? You're not going to be able to just sit down and do it in your head. And you're not going to be able to knock each problem out in like 2 minutes. Each problem is going to take you at least a half an hour, I'm guessing. They're word problems. And they're trying to train your brain to think the way you need to think to do physics. So this first problem set that is now already on Wiley Plus, if you look on it, you'll see it when it's due. It's due this coming Monday at 11:59 p.m. It's all submitted online. It asks the questions, you enter your answers, you click submit. It tells you right away if it's right or wrong. You get 5 tries with each problem. If you get the right answers within 5 tries, you get all the points. Okay? I'm available to give you guidance. If it's before the homework is due, I will never just sit down and do it for you, but I'll give you guidance. If it's after the problem is due, but you still want to know about it, and I highly recommend, if you didn't get one of the problems, it's already past the deadline, but you still say, wait a minute, how do you do that problem? I'll talk about it in any level of detail you want. But that's the homework. And it's going to be due, here's the rhythm I talked about, twice a week, Monday night and Thursday night. Okay? Your first set is due Monday night. There'll be the next one due the following Thursday. And it'll just keep going. So it's important to keep up. Plan on working on Wiley Plus problems a little bit every day. That's a way, I think, to not feel quite so overwhelmed by it. But practicing physics problems is how we teach you how to think like a physicist. Okay? Just like doing anything that's challenging takes practice. Any kind of sport, any kind of musical instrument, right? Practice. Okay. We do have a physics department tutor who, free of charge, will give about 4 hours a week of his time to help you with homework. Again, won't actually do the homework for you. You've got to do it, but will give you hints and guidance. And what he's planning on doing is holding a Google Meet where you just drop in. So what I'll be doing is sending you the links. He will be available Monday evening from 6 to 8 p.m. and Wednesday evening from 6 to 8 p.m. Once I send you the link, there's two separate ones, one for Monday and one for Wednesday. Just click on the link at the appointed time, and he should be there. Okay? Question here? Absolutely. Okay. No other questions? Okay, we have a half hour left. So what I'd like to do, I know this may have been fast. Hopefully the technology is working. When I send you the link, you can watch this all over again if there was something that would be helpful for you to see again. But what I want to get to now is the way most of the classes are going to go. That is doing physics. Okay? So, again, the pattern, the rhythm. There was a video lecture. I sent you the link for it yesterday for today's class. The way you know is you just look, does it have the date for the class? It had the date Friday, August 21st. So you know that's the video lecture for Friday's class. And it was a summary of Chapter 2, Section 1 from our book. Okay? Again, it's really important that you watch the video lecture before you come here, because I'm not going to say all that stuff over again. I'm going to pick up right where that left off and start using the ideas from that lecture. Of course, it's your chance to ask any questions about anything that was in the lecture that you found unclear or confusing. And we're going to do hopefully a lot of back and forth because we're just going to be doing little simple calculations. You have a question.
Given the instantaneous velocity, are we allowed to, if we know how to just calculate the derivative, or do we need to use the limit?
Nope, you can do the shortcuts if you know it. I'm in fact going to teach everybody the shortcuts on Monday in Monday's class. Okay? Okay, so one of the things I'll do on our in-class sessions is list what are called the learning objectives for the day's class. I'm not going to stand here and read these to you. You can read these for yourself. These are in the book too. In section 2.1, you will find this list of learning objectives. At least it lets you know, hey, here's what you need to be able to do for this section of the book. Okay? Okay, so what I want to do next, let's see if hopefully this will all work. We're going to do a little practice problem, okay? That is indicative of the kinds of conceptual questions you'll find in our book and is good practice for developing in you the way of thinking that physicists use, because it's quite a unique way of thinking. I will tell you right now, physics thinking is not your everyday intuitive thinking. That will only get you so far in physics. That's called fast thinking. Your intuitive, your gut. Okay? Which, by the way, is how you would probably do the pre-assessment test. Go with your gut, because that's all you've learned for now. But what we're going to develop is a slower, systematic thinking. That's what you need to do physics. So here we go. Let's start to work together on an example problem. We got a figure. You have to get used to these kinds of pictures. There are going to be a lot of them that are similar. It shows what are called four paths along which an object can move from a starting point to a final point. It does these motions, all four of them, in the same time interval. All four in the same time interval. You may assume the motion is along an x-axis with the plus x direction to the right. So you can imagine a plus x-axis to the right. And these objects are moving on that axis. That's what this is representing. The paths pass over a grid of equally spaced straight lines with spacing d, as you can see there. Okay, here comes the first question. Rank these paths. We're going to do a lot of those ranking exercises. List from biggest to smallest. Okay? Rank the four paths according to the average velocity of the four objects, greatest first. Oh, and there may be ties. If so, you have to indicate. Okay? All right, so I'm going to guide you a lot for this first one because you're not used to how we're going to approach these. Okay? First, the key thing in this practice is to keep track of what they're asking for. Average velocity, yes? It even puts it in bold. You do need to use the symbols and notation that our book uses, because that's what I'm going to use. And if we're not all talking the same language, it's going to be confusion. Okay? So if you watched the video and or looked in the book, you will recall that the symbol we use for average velocity is V sub AVG. Yes?
Real quick, is there a way we can view the PowerPoint right now so we can take snaps?
Is there a way you can what?
View the PowerPoint with you?
I'm not sharing it if that's what you're asking. Sorry, I don't know. There might be a way to do that. Maybe I can figure that out. Okay. Okay. So, anybody remember? I said in the lecture that 3 lines means defined. What is the definition of average velocity?
Delta x over delta v.
Change in x over change in time. Anybody know what the delta x's name is? Displacement. That's exactly it. Delta x is displacement. Displacement is change in position, right? You got to follow definitions of things. You can't make up your own rules. Change in position over time interval. So now tell me, if you think about it, if you're going to rank this quantity for the 4 paths, apparently you've got to think about what this is for each path, right? What's the most important part of this? Because that's the same for all of them, isn't it? It says so. Got to read carefully. So don't worry about the delta t. It all boils down to what's the displacement. We've got to be able to find that correctly. I recommend you make yourself, because you got to be organized, a table. You got the 4 objects or the 4 paths, however you want to label it. For each one, I want an expression for delta x. We're going to use symbols a lot in this class. Numbers only are done at the end, if ever. Symbols are actually better. Okay? So I want a symbolic expression. So now we've got to see if we can figure out delta x for each path. You see how they're trying to convey in a picture how these particles are moving on this x-axis? So what do you think the displacement is for particle 1? Let's see if I can give somebody who hasn't. Yeah, Jacob.
1 unit or d.
Okay, right? Because if you remember from the lecture, delta x is x final minus x initial. That's all it means, but it's got to be in that order. X final is here, x initial is here. X final is to the right of x initial, isn't it? That's important. That means x final is larger than x initial. The delta x is then positive, and it's 1 spacing, so plus d. That would be the displacement. What's the displacement for particle or path 2? Yeah.
Also plus D.
Also plus d. Right? It doesn't matter that when it backtracked and then came forward, does it? Just what's x final and what's x initial. And x final is to the right of x initial by an amount d. So another plus d. How about 3? That's an easy one, isn't it? Plus d. Now 4 is a mess. That particle didn't know what it was doing. Thoughts? Yeah.
Plus d.
Still plus d, isn't it? It's not hard if you understand the ideas. They're just trying to see if you understand the ideas by throwing literally a few curves at you. Okay? So tell me with this information, what's the ranking of the V averages? They're all equal, aren't they? It's a 4-way tie. I would write it like this. It looks kind of weird to a mathematician, right? But I'm just saying that that path and that path and that path and that path all have the same average velocity. Okay? It's conceptual. It's not a long calculation. It's just, do you know what average velocity is defined to be? And can you figure out displacement? Now let me do another one. I didn't say much about this quantity in the lecture, but I want to mention it. Rank the four paths according to the average speed of the four objects greatest first. Why did I want to do this? Because to an everyday person, these two things sound like they're basically the same thing, don't they? Average velocity and average speed. In everyday life, people would use those phrases synonymously. Not in physics. You have to follow the definition of the thing. Here's the symbol I use for average speed. SAVG. It's defined to be, I'm just going to tell you, distance traveled over time interval. Isn't that the same as delta x over delta t? No. Watch out for that. Distance traveled is not the same necessarily as displacement. So in this case, we have to rank S average. So what's the key thing I have to rank? Distance. Distance is just ground covered. Total ground covered. How much ground is covered for path 1? D that way, and D back. Ground covered. Okay? So 3D. What's the distance for 2? 3D. What's the distance for 3? That's an easy one, isn't it? D. What's the distance for 4? Oh, what the heck? All I have to do is the ranking, so it's still okay. We can figure it out. Let's just say for the sake of argument, that's the midpoint, there and there. Let's see. 1, 1.5, 2, 3, 3.5, 4, 5. Isn't it? 5. So what's the ranking of the average speeds?
4, then 1 and 2 are tied.
Okay? It's not hard, is it? But read the problem carefully. Ask or answer what it asks you. Don't make up your own problem. And you do have to get used, and this book does a lot of picture situations. Because you have to be able to read information both in text and in pictures. I include graphs as pictures, by the way. Okay, now, I hope this hasn't closed out on me. Yep, I was afraid it was going to do that. This is one of the things about Wiley Plus that will irritate you. There are probably many things that will. It shuts you out after a certain amount of time. Now, one of the things I want to talk about next, I can find it here. This is partly cut off. I apologize for that, but I can't get this to go any lower. Hopefully you can still see enough of what's going on. I want to talk for just a minute about position versus time plots. Very useful in studying motion, like we are doing in Chapter 2, motion along a line. Okay? Top part is the actual physical scenario. X-axis, X is in meters. There's a particle, it's a bead, that's threaded on the x-axis and can slide around. And something's moving it, I don't care what. And when you run the animation, you'll see it move. Okay? So let's just do that first. Don't worry about the graph at the moment. Watch the bead, because that's the physical object. It just moves, right? I mean, you can see, you can observe it. You can observe how it moves. Do you see where it started? It started there. It went over here, slowing a little bit, stopped somewhere over here for just one instant, and then was speeding up and went on and on back this way. That's an actual motion of a particle. We want to describe that mathematically. One of the important things we do is we make a position time plot, or x coordinate versus time. X coordinated meters is on the y-axis. Time in seconds is on the x-axis. Watch out for the naming, right? X is along, let's say, vertical, and t is along horizontal. Okay? That's called a position time plot. See the blue curve? That's a abstract representation of what that bead actually did. And you got to be able to see this graph and visualize the motion in your mind's eye. Because the graph is telling you the story of the motion. At time 0, it was at x equals 2. And as time went on, the x got larger, a little bit larger than 4, where it peaks. And then as time goes on, the x goes back the other way. It's telling you the story, what you just saw. Okay? So that's handy. Here's the other thing that's handy about it. You can use a position time plot to find what's called the average velocity for a time interval. Turns out, pick a time interval. How about the one I've labeled A here, which starts at t equals 0 and ends at t equals 1 second? And you can ask, what's the particle's average velocity over that 1 second time interval? Turns out all you got to do is take the points on the graph at time 0 and time 1, there they are, draw a straight line between them, that's the black line, and find the slope. And that'll be the average velocity. Why? Because slope of a line is rise over run. Yes? Rise is change in whatever's plotted this way, and run is change in whatever is plotted this way. So there's the rise, delta x, because it's x going up that way. There's the run, delta t, because it's t going that way. And the slope then is delta x over delta t. But that's the definition of V average. So all you got to do is figure out the slope of that straight line, and you've got the average velocity for that time interval. Who's got good eyes? Can we figure out what that average velocity is for that first time interval? You got to be able to read numbers off the graph. We're doing this for the time interval I've labeled A. Can you tell me what the delta x is? Say again?
2.75.
Well, it's exactly 2. Because x final is 4 and x initial is 2. Yes? So the delta x is 2. Plus 2 if I want, and meters if I want to be very careful. What's the delta t? 1 second. So what's the average velocity for that time interval? Plus 2 meters per second. Okay? The plus is telling you that the x final is larger than the x initial. Let's do this other interval. How about the interval that begins at time 0 and ends at time, it's hard to see, I know, 4 seconds. That's what the interval I call B. Let's do that one. Tell me what the delta x is. You understand what interval I'm talking about? Yeah. So what is it? -4. Because x final is -2. X initial is 2. -2 minus 2 is -4. So -4 meters. What's the delta t? 4 seconds. So what's the average velocity for that time interval? -1 meter per second. There's the line. I draw it dashed here, but it clearly has a negative slope. Question? First Love, and then we'll do Hannah.
So I think, I don't know, I feel like the delta needs to be 3 seconds.
The delta what?
The delta
T?
yeah.
For interval B?
Right.
T final is, it may be hard to read, but it's 4.
But I think we want the 4 seconds.
But T initial is 0.
Are we using delta T or
Delta TB.
right? So are we adding A?
No, nothing. I did A. Now I'm looking at B. They're completely separate things.
This is confusing with the double arrow.
The double arrow is meant to invoke size. Just there's an interval of this size.
Because it overlaps with.
Yeah, it's hard to see where it starts. It does not start here. It starts here. Okay? So delta TB starts there and ends there. That's why it's 4. Okay? That's one thing that's got to be clear. What interval are you talking about? Okay? You have a question.
In this situation, speed would be the same as the velocity you have, average speed.
In which interval? A or B or both?
Both.
No. Average speed and average velocity will be equal if in the given time interval, displacement and distance traveled are equal. Because those are the parts for each of those definitions. V average depends on displacement. S average depends on distance traveled. If displacement and distance traveled are equal for an interval, then yes, V average and S average will be the same. Is that true for A and B? Let's do those one by one. Is it true for A? Yeah, because all that happens in this interval is the x goes from 2 to 4, straight out. No backtracking or anything weird. So delta x and distance, both the same, 2 meters. What about interval B? No, there's a difference now. Because in interval B, the particle starts here, goes out here, and then it backtracks back there. So the delta x and the distance traveled will not be the same.
And so you could say that for either, velocity and speed would be the same in either direction. Well, the magnitude of the velocity and the speed would be the same in either direction if you were only going in one direction.
Yes. You can't do any weird backtracking and then turning around, right? Okay, yes, question?
So you start from the initial point and just take the final distance. You ignore everything, right, for speed?
For speed,
Yeah.
you just need to know where did it start, where did it end up, and what did it do to get from start to end. Because you got to note all the ground covered. Did it come out like this? And then did it go back like this? And then maybe go back forward this way? You got to find the whole distance traveled for S average. But for delta x, you don't need to know any of that. You just got to know where did it start and where did it end. Now, I don't care what it did in between, in fact. Okay? So V average and S average really are actually rather different things. Okay. Now, let's see. What I want to do now is I want to set up, I won't have time to finish it, I don't think, but I'll set it up, a full-blown example problem. This is indicative, gives you a sense of what a Wiley plus homework problem is going to be like. These other little things were conceptual to get our brains working and make sure we understand the ideas. But we got to be able to solve problems. So this is a problem that involves average velocity. And I tried to give you a physical scenario. We got somebody playing softball. Hits the ball with the bat while at home plate, immediately starts to run towards first base. Okay? The first base line is our x-axis with home plate at the origin. Okay? That's the first base line going out. You can see first base is at x equals 18.29 meters. So what the person does is they hit the ball, they start running, they go past first base to this point labeled A. They overrun. And then they backtrack and come back to first base. That's all. All right? Home plate, out to point A, and then back to first base. Everybody clear what the scenario is?
The distance from point A to first base, 6 meters. Is that what that is?
That's what that means. That's right. You have to be able to look at that picture and say, oh, that distance, which they've labeled L, is 6 meters. Here's some information. We're going to give you average velocities. Suppose the average velocity of this runner for the trip from home plate, the origin, to point A, and then back to first base, kind of the whole trip, you see what I'm saying, is positive 2.29 meters per second. While the average velocity for just the segment from home plate to point A, because you can break up the motion into parts if it's convenient or not, that's positive 4.67 meters per second. They give us two different average velocities because they looked at two different intervals. Here's the question. What's the average velocity of this runner for the segment from point A backtracking to first base? That part. What's the V average for that? Okay? All right. As we start to do more examples, you'll find that I want you to be very systematic. And I follow the method called STEMS for solving a problem. It's an acronym. S stands for sketch. Sometimes the problem gives you a sketch. Sometimes it doesn't, and you have to do it yourself. That's a sketch showing the physical situation. So you don't have to draw a sketch. Then tabulate. That's the T in STEMS. What do you know and what are you supposed to find? I know some distances, don't I? D is 18.29 meters. L is 6 meters. Notice how I'm writing sig figs in units. And I'm given some average velocities, but I've got to be very clear which average velocity is which, so that I don't get confused in my own mind. Okay? So, the V average, I'm going to call it V average, I'm going to call it segment 1. Okay? Segment 1 is going to be home plate to point A. And that is positive 4.67 meters per second. Then there's what I'm going to call V average net. Net means total for the whole trip. So home plate to point A and then back to first base, plus 2.29 meters per second. Home plate to A and then back to first base. You need to give yourself little labels so you know what you're doing. What I'm asked to find is going to be the V average for what I'm going to call interval 2, which is the part from A backtracking to first base. Okay, now, any questions on how I've set this up? Okay, we're coming up on 9:10. So what I plan to do first thing on Monday is pick up right here. So if you got this written down, or you can watch the video again later, what we've done is we've drawn a sketch. It was provided. We've tabulated things we know, labeling things carefully. That's going to be important for you to solve the problem yourself. And then I've also denoted what it is we need to find. The next step in the problem solving, the E in STEMS, is explain the physics you're going to use. The physics here is average velocity. That's the only physics you need. If you understand average velocity, then we ought to be able to go through and solve for the desired quantity. The M in STEMS is math. After you explain the physics you're going to use, then you start doing math. And the second S in STEMS is summarize, or what I call sanity check. Whenever you get your answer, you always say, does that make sense? Yes. You will always be required to show your work. You can do it in your head as long as what is on paper, what I grade, I can follow your thinking. All right? You can't say, well, I was thinking that. If it was an important step, it better be on the paper somewhere. These problems are designed so that they all can be solved. Yes. Sometimes it seems at first like you don't have enough information in a problem. And then you just got to take a deep breath, slow down, read it again, and think about it very carefully. Okay? So what we will do first thing on Monday is ramp right up and finish this off. Okay? Question here? What's that? I'm sorry? Yeah, that's up to you. You want to try it on your own over the weekend? Feel free. Don't forget over the weekend to start working on the Wiley Plus homework. Remember, it's due Monday night? You might want to make sure you watch my video lecture 1.1. Remember, I sent that to you already? That's my summary of chapter 1. If you want more, read chapter 1 in the book. Okay? But the homework for Monday is all about chapter 1. None of this stuff is going to be on the homework for Monday night. This is chapter 2. Is that clear? Yeah,
So this is 2.1 in the next class, are we going to be getting into 2.2 then?
correct. Okay.